Welcome back, guys, to this new video. And today we have with ourselves Rohit Segal. He is a security engineer. And today we are going to learn about something related to container security. So let's ask Rohit, what is the topic? Hey, Rohit, how are you?
Hey Karan, I'm good. So
Yeah,
first of all, yeah, thank you so much, Karan, for giving me the opportunity to come here. I'm really excited.
yeah, it's my pleasure too. So, what is the topic which we are going to learn today?
Okay, so today we are going to understand the attack and defense strategies in container environment. And when I say container environment, it's linked to Docker or Kubernetes. So we will start with understanding what Docker Kubernetes stuff like is, and then we will move to couple of attacks which are possible on infra deployed like created using Kubernetes. Yeah, this is what we are going to see today, and I'll try to make it fun in terms of like my entire presentation is in form of zines. So let's hope for the best.
Yeah, Zings is a new way of presenting, and it's a very fun way to learn the concepts.
Yeah, yeah. So I've tried to make the entire presentation in zines only. I hope students, everyone would like it. So yeah.
Yeah, and also like many people don't have much knowledge on Docker and Kubernetes and all those container technologies. So it's a great
Yeah,
topic.
yeah.
Yeah, so let's
Thank you.
begin.
Okay, cool. So uh, again, thank you so much, Karan, for introducing me and like giving me this opportunity to talk about attack and defenses in container environment. So today we are going to see what are containers and why do we need orchestration on top of containers and specific orchestrator, which is Kubernetes. After getting some idea about it, we'll see what are the different kind of attacks which are possible in container environment and how we can implement a couple of simple controls which can actually prevent those kind of attacks. We will also see some sort of configuration deployments, and then we will also see what are the best practices that we follow in here, and what is the future of container security. So this is the entire outline of our presentation or the discussion that we are going to have today. And I would like to introduce myself once more, although Prathan has already introduced me. So I am Rohit, and I work in the security field for close to 6 years now. I started as a developer in security team at Walmart, and I write a lot of tools on GitHub. You can check out my profile on GitHub at RBAC7. I experiment with a lot of new technologies. Kubernetes is one of them. And I think that's the only reason I actually love this technology. So I'm in extreme love with this Kubernetes and Docker. And yeah, I talk at conferences. Like in past, I've talked at a lot of conferences. Grey Hat, DEFCON groups, couple of them. And I'm also a cybersecurity SME at Upgrad. uh, I write security zines. So this is what I do, and I would like to share a couple of my experience as well. So I started as a BTech in CSE, did my masters in CSE from IITK, and masters I chose system security specifically. And then I got placed and I joined Walmart as a software developer in security team. Then I did my OSCP and then joined Walmart only as a security engineer, junior pen tester. I spent close to 2 years in there, moved to Visa in senior security engineering role. And after Visa, I moved to Gojek, which is now GoTo, is because of the merger between Gojek and Tokopedia. And I'm currently the staff security engineer at Gojek. So if you see, I have close to 4 years of professional working experience. And if you talk about security experience, like 2 years plus, because I've done my master's in security only. So yeah, that's something about me. Let's go into the topic for today, which is container and Kubernetes. This is a rough idea that we are going to see, which I've already talked in brief in my first presentation. Dockers, why do we need container orchestrator? Even why do we need Dockers and Kubernetes? Some sort of managed and unmanaged configurations in Kubernetes. Some sort of attacks, which is specifically I want to talk today is DIND exploitation, SSRF in Kubernetes, and supply chain attacks. And configuration related issue, which is RBAC and secrets. And that's the whole idea of the presentation. I hope you will enjoy this. So let's get started. Okay, so the first thing that we're going to see here is Docker. So what are Dockers? Docker is nothing new. It's just a isolation better than a VM isolation. So basically, it's a contained environment, which is not a virtual machine itself, but a lighter weight of lighter model of virtual machine. So when I say that, it's basically Docker is nothing but your application that you want to deploy in a VM, and the dependencies of that particular application contained in a specific unit known as container. So that's what Docker is, and it's similar to VM, but it is not VM. So VM are some sort of, you can call it as a hardware level abstraction, but Docker is like software level abstraction. So VMs and Dockers in terms do the same thing, which is isolation, but how they do it is actually their implementation. And what makes Docker special over VM is that you can actually scale your application, and you can make it OS independent and secure. So OS independent comes from VM also, but Docker gives you, like, containers gives a scale to your application and make them more secure. And how do they scale them? Like through orchestration. The couple of orchestration could be like Docker Compose or Kubernetes, and they make it OS independent by packaging it, and by they make it secure by actually isolating the app and actually creating a boundary around that application, so that the risk, the blast parameter is less. So basically, in case the application is vulnerable to some security attack, the risk is contained within that particular application, doesn't propagate, which is the issue with most of virtual machines. And yes, again, it's similar to virtual, but it works differently than VM. This is how a VM works. So you have a host operating system, which is actually performing isolation on hardwares to a specific virtual machine. So let's say if you have a guest, host OS will assign that hardware unit in terms of CPU or RAM to that particular guest OS, and this is how VM isolation works. But this is not how Docker isolation works. And in case of virtual machine, it's the responsibility of host OS to simulate hardware isolation. And in Docker also, it's more or less like same only. But container doesn't isolate hardware; they actually share hardware in a lighter way. We'll see that in next slide how that is possible. But yeah, this is the overlying concept of Dockers. And Docker is a terminology, but containers is actually, we call them when they are running in action. So yeah, containers. Now let's see how Docker is able to achieve this software virtualization, which virtual machine is not able to. So Docker containers uses the concept of Linux namespace and control groups to create virtually isolated environment for application. And in case of virtual machine, this is the hardware abstraction. But in case of containers, what they uses Linux namespace terminology. What are these namespace? Okay, so namespace are kernel resources. If you are coming from like Linux kernel development background, you might know what namespaces are. But you can think of namespaces as anything that is linked to kernel. So there are 7 different types of resources that you have, the 7 different types of namespace resources that you have in Linux. One is mount, which is responsible for mounting or virtual file system partitioning. Process for process one. IPC is for process communication. Network, as its name says, that making network visible and stuff. User namespace, UTS namespace, and the last one is the control group namespace. So like having these all 7 different namespaces and creating a namespace group. Like let's say if you want to create a contained environment which have specific file system access, specific user, and limited set of hardware resources, what you do is you create a mount namespace, you create a process namespace, you create network namespace, you create control group namespace, and then you create a user namespace. You create a set out of it and you call it as a Docker container. That's it. So it's nothing magical. It's just a software level virtualization. And uh, in all these namespaces, you see the control groups have the special namespace because they are actually responsible for allocating the hardware resources to a specific namespace. So this is how in brief Docker works. Yeah, let's see how you can like. I would like to give the couple of indicators about Docker. So installing is very easy. It's very specific to operating system. So I'll skip it here. Once you have Docker installed, you can actually run a Hello World container. And running a Hello World container is really simple. Once you have Docker engine and Docker command line installed, you can simply run Docker and Hello World. And if everything works, you can see the Hello World image being run through this Docker command. Yeah, it's that. And then we have Docker images. Docker images are set of pre-existing instructions that you tell to Docker engine. So basically, there are a couple of components. One is Docker container, which runs your application. Docker engine, which actually schedules your application inside a container. So if you see in the previous slide, we see namespaces and we created a specific set of namespace for a specific container. So that specific container namespace definition, you can think of it as written in Docker images. You can have Docker images in your local system. You can also have them in Docker repositories. A specific one, like the public repository, is Docker Hub. It's similar to Git repository. You can keep your Docker images in Docker Hub. You can mark them as public, and it's a public repository. But before pushing your images, you need an account here. So before pushing an image as well, after creating an account, you need to perform Docker login. And the thing is, where do you write those instructions? So you write those instructions in Docker file. So basically, you write those instructions in Docker file, build that image from that Docker file, push that image inside a repository, and then you pull that image to run it as a container. So this is the life cycle of Docker. I've written like this commands to build and push it. So this is an example. Let's say if you want to build, let's say some image from the current file, you can actually build it through this example, and you can push it to the next one. So this is not an extensive guide to Dockers, like how you can build and create Dockers. That's why I've given a very brief overview of what Dockers is. Okay, now we have contained the application and everything is working fine. But the question comes is like, why aren't Docker sufficient? Like, why isn't this technology sufficient? Why do we need some sort of orchestrator or Kubernetes on top of this Docker? Now let's see a scenario. So you have your Docker running inside a node, and the same node could be running a couple of Docker containers together. Now, what will happen if this particular node goes down? So when I say node goes down, as in something bad happens to this VM and VM crash or something happened and the node goes down. So as soon as the node goes down, the application or the containers which were running inside the Docker goes down as well. What will happen to them? So one thing is that like availability. But what we can do is we can add our flag on Docker while running the Docker, by which the flag says that like just restart set as always. But this will only work if your node comes up. If the node doesn't comes up at all, let's say you have properly decommissioned that node completely, your application like is gone forever. So this kind of scenario, Docker was not able to handle alone because it was not designed to be in that way. It was just designed to run a contained application, and that's why this happened. Um, the another thing is, let's say if you want to move that Docker from one machine to another machine, the Docker itself did not have that capability to move it from one machine to another machine. So that's the biggest challenge that's why the orchestrations are needed. The next thing was load balancing and replicas. So let's say if you want to build same replicas of same image in couple of containers for availability, and you want to load balance this with the Docker. So this with Docker was not really possible. This kind of service abstraction was not really possible on top of Dockers. And the next thing was, let's say if you want to upgrade your image, like the Docker image that you have written, you want to upgrade it, but you don't want any downtime. So rolling upgrades were again not possible. and distributed workload. Let's say if you have multiple computes like distributed environment and you want to allocate your workloads across different resources in distributed environment. So this was not again possible with Docker. So that's why we need something called as orchestrator on top of it. But Kubernetes is not just one of those orchestrator. We have Docker Swarm, which is an offering from Docker Inc., who proposed Docker and made Docker open source. And then we had Kubernetes, the really popular one. We have Red Hat OpenShift, which is a orchestrator for containers as well, and Nomad and Rancher and Meso. So these are a couple of really popular containerization orchestrator, which can orchestrate basically the container methods. Okay, but in this presentation, I want to talk specifically about Kubernetes because I just want to discuss about the kind of attacks. And Kubernetes is also really popular. That's why I picked up Kubernetes specifically. And I'm not really aware of other different kind of orchestrator apart from Docker Swarm. That's why I've not picked them. Right. Now, Kubernetes is also known as K8s because in between K and S, there are 8 letters, and sometimes referred as K8s. Cool. Now, what makes Kubernetes different from Docker containers? So, in we know that containers exist, right? But the Kubernetes has taken it to another level, and what it does is it will create the set of containers and mount not mount basically it will just call the set of containers as a pod. Instead of just containers, it is creating a fundamental unit name as pod, and each pod may contain couple of containers, not just single containers. Basically, the fundamental unit now here is a pod, which in case of Docker was just a container. And why it has been done, it's a good and detailed discussion in itself. But as of now, just think that in Kubernetes, we just don't deal with container, we deal with set of containers. A pod may contain multiple containers. In an ideal situation, one container per pod is sufficient, but there is a possibility that a pod may contain multiple containers. And Kubernetes starts from here only. So we have a pod and couple of and various containers inside pods share all the resources. So when I say resources, it would be network storage and all other namespace resources that we see exist in the context of Docker containers. And what we do is this is the fundamental unit that we call as pod. Kubernetes is called in Kubernetes terminology, we call it as a resource. So we have various types of resource in Kubernetes. So one is pod, service, replica set, deployment, secrets, load balancers, stuff like that. So you have lot of resources, and so you have basically a lot of fundamental resources in Kubernetes. And what you do is you write a specification of those resources. So let's say if you want to build a pod having these two containers, you'll have to write a specific YAML file which will give the declaration of how you want to build those containers out. And that specification is known as that specification we do in a YAML file. We call it as a spec file. And you write a spec file for all the resources which are there in Kubernetes. Again, writing spec file is not I'm not planning to cover it here because it's again a different topic in itself. But yeah, these are the resources, and for each resource, you can write a specification. The specification is in a YAML file. YAML file is very simple notation of declaring stuff. Cool. The next thing I want to talk about is Kubernetes architecture. The Kubernetes works on a master and a client model. And in each Kubernetes cluster, there is a master node, which is known as control plane as well. And there are more than one client nodes. Although master can be more than one as well. But for simplicity, let's assume that in our architecture, we just have one master node and two client nodes. Now what happens is each Kubernetes master has something called as Kube API server, which is, you can call it as the manager or the prime minister of the entire cluster, because that is responsible for doing every single thing inside the cluster. Then you have a kube scheduler, again out of scope for here, and kube controller manager, again out of scope for here. But in short, what they do is they see kube scheduler see that in which node I should schedule a pod, and in controller manager just keep track of it, and everything is recorded inside a database which is known as etcd, which is present inside master. And each Kubernetes client node contains a service which is known as kubelet, and kubelet is responsible for receiving requests from master and performing the request request how should I say, so performing those request requirements on the particular client. There is also one more component which is known as kube proxy, and there could be more than one master available inside a cluster as well. So there could be multiple masters, there could be multiple clients. The architecture is really simple. I want to talk specifically about the architecture here because there is one thing that I want to talk about is SSRF issue in Kubernetes, which is a basic attack that happens. So to discuss that, I just wanted to tell about the Kube API server, that how the Kubernetes works. So it's a server, it's a REST server that receives requests from client, and you could be the client or some application could be the client, and then on the basis of that particular request, it will go and perform operations on entire cluster. So yeah, that's the architecture of Kubernetes cluster. So what you do is, as a client, so let's say that's me, and I want to connect to this particular Kubernetes cluster. So what I'll do is I'll fire a kubectl command. Kubectl is a client for Kubernetes cluster. That kubectl client will talk to Kube API server. Kube API server will talk to Kube scheduler, Kube controller manager, etcd, perform the necessary operation on there. What are those operations? I'm just omitting them for now because it's not scoped for in here. And then once Kube API server receives green signal or in here is blue signal, so signal from all the different components, it will go ahead and ask a specific kubelet in any of the client based on the information that it has got from Kube scheduler and Kube controller manager. It will go and schedule a pod inside inside a specific client. So this is how the entire process goes like. And your pod is nothing but a collection of containers which runs your application. So basically, your application, if you see, is running inside this specific Docker container. And the entire process that how it happens, this is the flow that it happens. And once the container is scheduled, Kube API server receives the OK response, and then it passes the same response back to the client. And yeah, that's the very basic idea of Kubernetes architecture. And yes, you may have a couple of different pods or different applications running inside different pods in different client nodes. In Kubernetes, you have distributed storage, and that distributed storage is also known as persistent storage. That is not at all on nodes because you want to make that storage available across same containers running in two different pods. So if you remember in the previous slide, I showed that there is a replica of the same pod. So let's say the replica of the same pod belongs to two different nodes itself, then the storage cannot be on a specific node. The storage has to be central. So what it does is, like, if the pods request the same storage, they can access the same storage, and that storage is not belonging to the node; it's belonging to somewhere else. So it's uh, it's a cloud storage, and in Kubernetes we call it as a persistent storage. And persistent storage can belong to same pods or different pods belonging to different nodes. So that. The next thing I want to talk about the underlying infra. The underlying infra can be physical as in bare metal machines. You can actually create the Kubernetes cluster on bare metal. You can create on virtual machine. You can create on a private cloud, also on public cloud, and then on hybrid cloud as well. Again, I'm not getting into those details because we want to talk about the issues or the attacks in Kubernetes environment. So I hope this overall idea of Kubernetes and stuff is clear to you guys. Cool. Now let's talk about different configurations of Kubernetes deployment. So one could be managed, and then another one could be unmanaged. So in case of unmanaged, we saw that we have a master and we have a client. We create a master using kubeadm init, and we connect to that master using kubeadm join. But the issue with unmanaged cluster is that we have to perform components management, and then RBAC is not properly implemented, loose disk configs, and weaker Kube API server best practices. So basically, unmanaged is like when you are taking two different virtual machines and setting up your Kubernetes cluster by yourself. So it's not just running two different commands, it's actually a lot more than that. And that comes into an unmanaged part. But in public cloud, we have offerings from Google. So GCP Cloud has GKE, which is the managed Google Kubernetes engine. In AWS, we have, in Azure, we have AKS, which is Azure Kubernetes Service, and in AWS, we have EKS, which is Elastic Kubernetes Service. And these are the managed instances of Kubernetes. So it's very easy. Just go to the console and perform a couple of clicks, and then your entire cluster will be set up automatically. And yeah, so now I want to talk about specific to GKE, which is Google Kubernetes Engine, and I want to talk about two different configurations of GKE, which is the private and public accessible Kubernetes cluster configuration. And I will show you how a public accessible Kubernetes cluster can lead to insider threat. So we already have that Kubernetes cluster architecture with us. In publicly accessible GKE, what Google does is, or GCP does is, it will create two different VPCs. The one is a VPC for your project itself, where your node would reside. So this is your project VPC, the wide boundary. And then another VPC is Google managed VPC. And in the master always lies in Google managed VPC. So you will not at all have direct access to the master node, but you might have access to client node because they belong to your project VPC. And the control flow is same, just that you hit Google managed load balancer and get data from here, and perform the kubectl requests from your system. And the only thing is, like, you are actually connecting to Google managed LB, which is talking to control plane, and then control plane is responsible for performing the commands over there. Now, how this happens in Google or in GCP, what you can do is you can download cluster config in your system. That cluster config will actually authenticate and authorize you across your control plane. So in this system, which I am accessing right now, this there you can see there is an access. There could be an access stored. Using that access only, I'm getting authorized and authenticated to the Kube API server. But now, since that Kubernetes control plane config is stored inside a host, it can be easily copied to some other machine as well. So let's say if I copy that cluster config from one machine to another machine, now that machine may access your public cluster if you have not restricted your public access at all. And this is very good example of insider threat. So let's say if I work in a specific organization, if I take that cluster config from one machine to another machine, and after leaving that particular organization, I still can access the entire cluster. And if your production grade services are running inside the node, then this could be a serious challenge for your organization to restrict such accesses. So with public accessible GCPs, these are the issues. Like, it is susceptible to insider threats. That's why it's not encouraged to have publicly accessible GKE. But what's the solution? The solution is privately accessible GKE. In privately accessible GKE, you have a jump box, and that specific jump box lies in your project VPC. And then only the Google managed VPC will only receive the request from a specific machine which is inside your project VPC. And what you do is you connect to a VPN tunnel, and through VPN tunnel you issue those commands over this jump box. So the entire effect can be achieved, but you have to go to that particular cluster over and jump box. So in case if you pass that cluster configuration to someone else as well, uh, it the person, since will not have access to VPN, will not be able to access it if you have properly configured your VPN. So that's one of the attack and one of the defenses across GKE deployments. So always make sure if you have Kubernetes engine, make sure to have it in a private configuration. Public configurations are not at all safe. Okay, the next issue that I want to talk about is SSRF in Kubernetes. Okay, so since we discussed that Kubernetes master have Kube API server, and Kube API server runs on a specific port, which is 6443. Let's say if you have a SSRF vulnerable application running inside a client, what it can do is it can actually reach out to the services inside master plane And I forgot to tell you that in master, every different service which I mentioned, like every different service, which is like Kube API server, Kube scheduler, Kube controller manager, and even kubelet in kube proxy, they runs as pods only. So they are nothing but pods. They are not running as individual services. They are running as pod inside a specific isolation. So your kube API server itself a pod, is itself a pod, and you have SSRF vulnerable application residing in the client side. So let's say if that is the case, now there is a good possibility that if attacker is able to access if attacker identifies there is a SSRF vulnerability in your application, what it can do is it can leverage this SSRF to get in some important credentials from this Kubernetes API server. But it is not easy. I would like to again say that, because Kubernetes requires you to have authentication and authorization to access Kube API server. But this would become really simple if you have a Kube API proxy running on top of it. So in Kubernetes, there is a proxy which can actually simplify your access. Now, if that proxy is running, which is there, like which I've seen myself like running in most of development environments. So if that proxy is running, there is a good chance that attacker might be able to access Kubernetes cluster specific information, which it is not required to do so. And this happens because in Kubernetes there is something called as service network mesh. Service network mesh says that every pod, irrespective of isolation that it is in right now, that pod can access another pod. Like any pod in a Kubernetes cluster can access some other pod. And since our services, including our cluster management services, is running as pods only, you can access them from any pod. So that's the network mesh. And just because of that only, you can actually connect to other services. When I say services, as in other pods which are not at all part of your isolation, or basically your not network boundary. So what might happen is, like, if you have uh, if in your production there is SSRF vulnerability, that SSRF vulnerability itself can talk to other services inside the same network. So basically the risk boundary, or the risk boundary is actually increased in that case because of the service network mesh. And this is by design in Kubernetes. So basically we'll have to take care of applications, the vulnerabilities in the applications doesn't propagate properly to the network. Yeah. Okay, so let me show you a quick example of that. So i'm using this service which is known as Kubernetes Go. It's a really good vulnerable Kubernetes scenarios which are which has been written by Madhu. So Madhu has written this, and it's if you want to experiment with the security issues inside Kubernetes, you can actually go ahead and perform a couple of checks on like how you can exploit Kubernetes services in this Kubernetes board. I have deployed the same instance of Kubernetes board in my local system, in the local cluster that I have, and yeah, we'll try to see. Now, since I know that there is one more service running in my let's say local host 5000 port that can take GET request, content header is something similar. It's not required. So I know since there is one service running inside my local host, like in the same pod on 5000 port. So what I can do is, for a service running on 1232 port, I can actually perform a SSRF on a GET method. So let's say if I perform submit, I can actually get the information from there from that. And since it is saying that please refer to the internal HTTP metadata DB, what I can do is I can even hit this particular endpoint. I might not know what comes, but yeah, I can hit that endpoint as well. So yeah, yes. Okay. So this is what SSRF in Kubernetes looks like. And again, SSRF is possible in Kubernetes because of the Kubernetes service, because of the Kubernetes service mesh. What that service mesh says, every pod inside a cluster can access other pods inside the same cluster. That's what the service mesh says. Cool. The next container related vulnerability that I want to talk about is not vulnerability as such. The exploitation scenario that I want to talk about is DEND. DEND is a popular concept which says like you can actually run a Docker inside a Docker. If you have followed me so far, in the first slide, you would have noticed that you you can run a container inside Linux because Linux offers you the um, flexibility of namespaces. But you don't have that same flexibility inside a Docker, because in Docker everything is restricted. You only get the span of namespaces, like the set of namespaces. But what Din does is it will help you run the Docker inside Docker itself. So let's see how that happens. But to understand how that happens, we will see how Docker engine talks, or basically this command, which is the Docker command line command, talks to Docker engine. So this when you run Docker run, let's say Alpine that you want to run, it will talk to a Docker socket, which is usually running at this particular location inside your host, where run docker.sock. And this docker.socket actually takes the command from Docker and give it to Docker engine. Docker engine is actually the master of entire cluster configuration. Not cluster, basically the container configuration. So it will take your input from there, and then since it is saying that it has to run a new Alpine SH Docker, it will create a new Docker, run that particular app inside it, and yeah, this is how it happens. But the DIND takes this to next level. So if you see it here, let's say if you have this socket, this specific socket, which is var run docker.sock, available as a socket inside this Docker as well, and you have a Docker command installed inside this container, the container can access the same Docker which is at the host. So how this can happen? So this can happen through this command. So let's say I want to run the same Docker, but this time I want to mount my socket to Docker socket. So this is a command to mount the host to basically the to the path inside the container. And if that happens, and in case if this application, sorry, in case if that happens, what will happen is you will have the same socket available inside the container. And in case if this application is vulnerable to some sort of, it is vulnerable, let's say a specific vulnerability, command injection. So if this application is vulnerable to command injection, you can actually exploit this presence of this Docker socket. And with this exploitation, what you can do is you can actually reach to the Docker socket which is inside the host, because it's a volume mount you have done. And the same Docker socket can use to connect to Docker engine that we have already seen. And once it connects to Docker engine, you can actually reach to all the containers which are running inside that particular host. So sharing this Docker socket to another container is really risky, but we have a lot of applications doing it. One example of that could be the pipelines. So let's say if you use GitHub pipelines or GitLab pipelines, so they allow you to build a Docker image from a Docker file inside a Docker itself. So Docker inside Docker is very frequently used in build pipelines or in DevOps. So that's why if you are mounting or if you're performing any sort of such operation, always make sure that your container is uh, very well tested. The application inside the container is very well tested. And if let's say if you use any sort of non-trusted image as well, which is the classic example of supply chain attack. So in that case also, you might lose access to your socket because that application might talk to your Docker socket, provided that you have mounted that socket. So um, let me take you another example in the same Kubernetes Go environment. So in the same Kubernetes Go environment, there is a portal, and this portal says that you can actually ping your service. So let's say if I just want to ping localhost, you can see I can ping the localhost, and it's working like expected. But this particular web application is vulnerable to command injection. So let's say if I just perform ID command, I can see after ping, I can see the presence of ID, which is running as root. To see if Docker is mounted or not, I can see the mount command. The mount command will tell me what all mounts have been done in this container. For us, the most important one is to see here is custom docker.sock. So we can see that in the application which is running inside this particular application, which is running inside some container, is actually mounting the Docker socket. So we have Docker socket available. What is the next thing that we need to see? We need to see if we have, let's say, not mount, but the Docker command available. If we have Docker command already available inside the container, then we are good. We can actually start doing stuff on top of Docker. But if we don't have the Docker command, let's see what we can do. So first of all, let's see if we have the Docker command available. So Docker command is not available. And since this is command injection vulnerability, what I can do is actually I can install Docker inside this particular container. And what I can do is I can actually pull Docker from here and move it into temp Docker, like some directory. Since this is the download operation, it will take some time for this operation to get. So I'll just submit it and wait for the command to get over. It will take some time because it's a download operation and it's downloading this Docker file from docker.com. And once we have this Docker file available, what we have to do is we have to just unzip it, and then we have to run Docker. And once I run Docker, I will show you how I can connect from this particular application through this Docker socket and fetch the information about these containers which are running inside this host. So we'll wait for this to get over.
Okay, so till it happens, let me summarize because we have gone through a lot of information here. So
Okay.
first of all, we saw what is Docker, how it is made, like how it works and it is configured, and then we saw like why it is not sufficient. So we required Orchestrators, which is one of famous one is Kubernetes, Q8S. And then we saw what is Kubernetes. We saw how it works, then how it is configured, also the architecture and the underlying infrastructures about Kubernetes. And also after that, we saw like how Kubernetes is managed and uh, like what are the specification configurations for Google JKE, right? Google
GKE,
Kubernetes
Google
Engine.
Kubernetes
Yeah,
Engine.
GKE.
Yeah,
Yeah. So we saw how like what configurations we need to do. And then we saw like how we can secure Kubernetes. What are the things we should keep in mind? And also after that, we saw some vulnerabilities. Like first one was SSRF, SSRF in Kubernetes. And then another one is which we are right now seeing the demo of, which is DINT, Docker inside Docker, right?
yeah,
Overall, if anybody did got what the topic well, rewind the video and check back so that everything is clear. Because for personally for me too, it's a lot of information to go through because this topic
okay,
is like new because uh,
exactly.
not many resources are available on the internet about it, and uh, many people are like mainly focusing on web and all those. So this container
Yeah,
security is new to lot of people.
I agree. I agree. So yeah, container, cloud, these are new terminologies which are coming up, and just because of that, like since the lack of resources is there, that's why I've come up with this idea of presenting
Yeah.
this.
Yeah,
So while
many
you were
many
talking,
thanks,
I
Rohit,
no worries, no worries. So
for
yeah, while you were
teaching.
talking, I actually decompressed the Docker that I've downloaded. So I've decompressed it with this command, uh, and I've decompressed it inside the temp directory. Now, since I have Docker running, Docker downloaded inside temp directory, what I mean is I'll just perform this ls -l and to see if I have Docker command available inside temp. So yeah, I have Docker command available inside the temp directory. So the next step is this one. Your application will use this socket to fetch resources from the Docker engine. Okay. For that, let me just fill this one. Okay. So this is saying that pick Docker from temp directory and pick socket which we saw in mount command. Use that particular socket to see what all Dockers are running inside hosts. So Docker PS is the command. Usually Docker PS is the command to list Docker inside host. But what I'm doing is I'm running this Docker command from inside the container and through this Unix socket to get the list of this all the Dockers which are running there. So I'll just submit it, and once I submit it, again it will take some time. So you can see what all are the containers which are running out there. And if I go back to my terminal, what I can do is I can run the same command docker ps here. It's not, so these are nothing but the pods which are running. These pods would have some Docker containers linked to it. Since I don't have this Docker, just one second. Yeah. So since I didn't have this Docker added to the group, that's why if I run it as a sudo, I can get the list of all the containers which are running. And this is nothing but same as this specific one. Okay, so yeah, this is what DIND exploitation is. So if you are planning to have this DIND socket mount, always make sure that your application is not vulnerable. In case if it is vulnerable, there are good chances that vulnerable application would have access to the entire container landscape. And this would apply to cluster, Kubernetes cluster as well. So if you see, I have hosted this specific application inside Kubernetes cluster only. And inside this Kubernetes cluster, I can access all the pods which are there, or basically all the containers which are there. So that's why always make sure if you are having DINT, make sure your application is good enough. Cool. Yeah, that's it. The next thing is like it is a short one. So secrets, and Kubernetes secrets aren't secrets. So basically, whenever you think of adding some sensitive information inside any specific code, what you think of like keeping sensitive information inside secrets. So these secret example of these secret could be GitHub variables or something like that. But secrets inside Kubernetes are not at all secrets. So uh, first thing, like you can use this command to create the secret. Secret is this one is a resource name. This is the name of the secret. This is like from where you want to create the secret, and this is the secret value bar. Now you can create a secret like this, but what I'm saying is secrets inside Kubernetes aren't secrets. So let's say if I go back to terminal and if I do Kubernetes get secrets, so I can get the list of all the secrets which are there. Now, since I have created one secret, what I'll try to do, I'll just try to get this value of the secret. And if I get, yes, I get the secret. But let's say if I want to get the value, I'll just do this. I'll just perform kget secret, and I'll just append this command with -o YAML. It will give me the secret definition inside a YAML file. And this is also the signature of a specific resource, how you write a resource inside Kubernetes cluster. If you see, this secret has a data which is known as foo, and its value is YMF5. If you're curious to know what you
Rohit,
can do,
sorry for the interruption. Can we increase the font size of the terminal a little bit? It's not.
is
Yeah,
better.
it's okay. Yeah.
Cool.
Thank you.
So no worries, no worries. So yeah, this particular value is not at all encrypted. It's actually encoded, and that encoding is nothing but base 64. So what you can do is you can actually perform base 64 minus d to get the value of this secret. So this is the last thing that I will talk about, that never assume that secret inside containers are actually secrets. They are nothing but just base 64 encoded. And if anyone have access to your cluster, will get access to your secret data as well, which could be your sensitive credentials, database password, and stuff like that. And always make sure to have RBAC policies implemented inside container. RBAC policies work like this. So you have actors. Actors could be users, groups, or service accounts. and each actor can have an operation linked to it or action linked to it. The action could be list, get, create, delete, patch, watch, something like that. These are nothing but the Kubernetes command. So if I take example of this Kubernetes create, create is nothing but an action. So secret is a resource and actor is the user who's running this command. So these are the actors. You have actions and you have resources. So what you can do is you can actually restrict user with policies for these resources. So basically, you write a policy. Policies again is a YAML notation. You will write a policy to restrict the access and just bound the access. So we call it as a role-based access control. So always, if you implement a cluster, make sure you have a RBAC policies implemented correctly. I think that's the end of my presentation today. I really hope that you enjoyed it. Uh, I would like to give special thanks to Madhu because Madhu has written really nice vulnerable Kubernetes environment, which is known as Kubernetes Goat, which I have also used in this demonstration. And again, really like special thanks to Kathan also for inviting me for this talk. If you like the idea of this presentation, I keep on writing such sort of zines, and you can find all of the zines in my website, which is securitysines.com. I hope you enjoyed it. Thank you so much. So over to you, Kathan.
Yeah, so like when you were explaining the concept, we get clear from Zing is also very good, but the uh, video with plus video explanation, it was like a gold, like overall clear everything. Like so, you should actually do this with zines. Also, make some explanations videos. So that will be a, like a goal mine to clear all the concepts and get the topic and all the information. So,
Really appreciate that.
yeah, because also, guys, I will link the zines where you can get these zines in the description. I will share the link. And lastly, to continue my summarize, we also saw which default encryptions is used, like base 64 is been used for encrypting, and also we saw some secrets and RBAC, right? Uh,
Are back.
yeah.
Yeah.
So one question that came to my mind was, can we change this base 64 default encryption?
Can we change this? Yes,
Like,
but will you change this? No. The thing is, it's open source, so you can actually go inside the source code and perform changes on the source code, but it's not easy. So if you talk about the current configuration, can you have some other encryption? No, we cannot have some other encryption as of now, as of this presentation.
okay. Also,
Just encoding.
like, mhm. Yeah, yeah.
Yeah, it's just encoding, and that is like basic step for encoding. So we cannot change that as well. So that's how.
So also one
So yeah,
of
I
the
was saying
question,
that.
yeah, continue.
No, that's okay. So I was just concluding that part that if you have to perform encryption over encoding in secrets, you have to do it this at the code level, and you just have to store the encrypted value, and in the code you have to read that value and decrypt it. So this is not at all in Kubernetes level. This is you have to do at code level.
Yeah. And also, while if, for example, you got an RC on a web application, and how can you escalate from that Docker? If you are in a Docker container, how can you escalate from Docker container to the root manager? Is it possible or is it not?
Okay, that's a good question actually. So if you have command injection or let's say reverse shell inside a Docker, there are good chances that you cannot do anything on top of it because the Docker are designed to be secure unless you make it less secure. So there are a couple of runtime configurations which can make your running container less insecure, but usually we don't use them unless there is a need. So privileged flag is one of those examples. So if you have privileged flag open, you are basically some way exposing host container services or the entire namespace inside Docker. So then yes, you can do something to get data from the host, but In a normal scenario, no, because Docker are designed to be isolation and secure.
Okay. And my final question is like, how can we find publicly accessible Docker instances and Kubernetes instances? Is it possible? Like for
Mm.
not in just a white environment, like in the company environment, uh, over the internet.
Okay, so the thing is, Docker is transparent. So if you have application running inside Docker, it will be transparent. You won't even know that there was something that application is running inside a container. So yes, that is not easily possible in most of the cases.
Okay, okay. Thank you, Rohit, so much. The knowledge you share was incredible. Like it was amazing. Like even though it was a lot of things, I have personally have to check the recording back because this topic is also
Okay,
new to me. So thank you so much for sharing this knowledge with us today.
sure. And Katha, what I'll do is I'll give you this presentation as well so that you can share it on your channel.
Okay, okay. Yeah,
Um,
I thought that this will be given in a zine, like we have to get it from your side, so I didn't ask.
That's also good. So I'll put it in my site. I can make it available,
Yeah,
and then you can give the link to that site so that people can check it out.
yeah. Thanks.
Cool.
Okay,
So yeah, thank you so much, friend. Thank you.
thank you. Bye.
Bye bye.
Wait. We missed one thing. Like, any last message to the audience? Like overall general message.
Okay, so containers and Kubernetes are new, and trust me or not, in future every application will be hosted inside these environments only. So don't wait for the right time to come. Rather, train yourself now because since the tech space is growing, the opportunities for security folks also in this domain is growing. Yeah, so demand is growing. Sooner is better than later. So start it now. I know this is really difficult for like a lot of people who are just thinking from web application side, but yeah, some like today or tomorrow you have to start it. So why not today? So just start with it.
Yeah, exactly. Okay, Rohit. Thank you so much. Bye bye. See ya.
Bye.
Thank you guys for watching. If you feels like to subscribe, then go ahead. Also, many more hackers are going to come on this channel in future. So until next time, peace.